Which of the following claims about the bond in HCl is most accurate? And then we have like an A through D type of multiple choice. Would it be that the bond is extremely weak? Would electrons are shared unequally, with chlorine having a partial negative charge? Is the bond nonpolar, or does the H atom have a partial negative charge? Okay, well, let's break it down. We have hydrogen, and we have chlorine. Now, for this type of question, we do not need to know how to draw the correct Lewis structure, right? We just have to know that hydrogen is a nonmetal, and if you can hear the commotion downstairs, I have no idea what's going on, but we must learn through distractions. Okay. So we know that hydrogen is one of our nonmetals, and chlorine also is a nonmetal. Right? This is like going all the way back in the day when we learned about, who's a metal on the periodic table, who's a nonmetal. Okay, cool. So we say that, okay, we have a nonmetal and a nonmetal. Those are covalent bonds. So basically, when you have nonmetals coming together, that's a type of covalent bond. That is not an ionic bond, which means that electrons are shared. And maybe I'll just put E minus, right? E minus usually you'll see throughout your course are known as electrons. Okay, so that means that in this bond, I have a sharing of electrons. But now we have two different types of covalent bonds. We have nonpolar covalent, and we have polar covalent. Polar, the P word, this pole, means that there is a unequal, quote unquote, pulling. So you could, put the P with the P. Pulling, polar. That just basically means that one of these atoms are pulling the electrons closer to it and not allowing the other element to really have it. Technically, yes, they're still sharing the electrons, but maybe one of the atoms shares it a little bit more, right? That's the pulling, the polarity of it. If you have nonpolar, that generally means that there's no pull, that everything is beautiful, it's symmetrical, and everyone is happy. The electrons are split right down the middle, 50-50. Basically like in this representation. So the question is there going to be polarity or is there not going to be polarity? Well, we can think of it in terms of the acronym SNAP, right? We could snap it out. If your atoms in the bond generally, doesn't work all the time, but generally if it's symmetrical, which means that everything is the same, that bond will be nonpolar. So these go together. But if your elements in the bond are asymmetrical, meaning that they're different, the general bond would be polar. And it kind of makes sense, right? If you have two different elements, you're going to have two different types of electronegativity, different types of attractiveness. In this case, I do have different types of elements. I have a hydrogen, which is all the way on one side of the periodic table, and chlorine is all the way on the other side. So the electronegativity values are going to be way different. So we know that this has to be an asymmetrical polar bond. So we've already gathered some information. We definitely know that it's polar, and we know that it's covalent. Let's see. Now, automatically C says the bond is nonpolar. So this is out. Okay. The second thing is this is literally a bond. It's basically shaking someone's hand instead of waving to them, right? Intramolecular forces versus intermolecular forces. Bonds are really, really strong. Takes a lot of energy to break some bonds. So by saying that this bond is extremely weak, that's not correct. Covalent bonds is the main way in which covalent compounds stay together. So they're relatively strong. They're not extremely weak. So we're down to basically B and D. Now, the thing that they are talking about, right, they say something about this partial charge, right? Partial negative charge or partial negative charge. Who has it? Does chlorine have the partial negative or does the H? Well, this comes from electronegativity. If I just quickly draw an electronegative chart on the periodic table, you should know the trend. That as we go from left to right, electronegativity increases. And just like we said before, hydrogen is all the way on the left side and chlorine is somewhere on the right. So that means that chlorine would be more electronegative. Oh boy. Stuff's going down downstairs, but I'm up here. More electronegative. Maybe I'll just say electronegative. Negative. Okay, beautiful. And the meaning is in the word. More electronegative. So that means that as far as these partial charges go, if chlorine is more electronegative, would that one have the negative charge? Or would hydrogen have the negative charge? Yeah, you got it. Chlorine would definitely have the negative charge, the partial negative charge. Partial always talks about covalent bonds, by the way. So if you have a covalent bond, you could only say that these are partial negative charges or partial positive because they're not full charges like ionic bonds. And we write those as these like cute little S things. These are deltas, but we would say partial negative for the chlorine, which means that the H has the partial positive. So this guy would have the positive, and that's why D is incorrect. The correct answer is B. Electrons are shared unequally, and that is true because it's polar. There's pulling. It's not equal. That would be nonpolar. With chlorine having a partial negative charge, and that's it. Okay, that's it for me. What do you think? Hope this helped. Let me know in the comments. Love talking to you guys in my spare time. And if you guys aren't on the website, head on over. glazersguide.com. Link will be in the description. My brother and I have made deep dive videos. We've made videos of basically the topics that you have to memorize for your tests and quizzes. And we've made these practice problems for you guys. So go on, check it out. Practice, practice, practice. That's how you get good with these, these science subjects. And we're there every step of the way for you guys. I hope you guys are having a great day. And I'll talk to you soon. Okay, bye-bye.
For more practice and for more fun, go to glazersguide.com.
And for more practice and for more fun, come on, go to glazersguide.com.